right, I got something to show you. I got something to show you. Come here, follow me. This is great. I got myself a lab, a secret lab. Nobody knows about it. Nobody does. Ignore that. Let's just go. Let's just go. Welcome to my laboratory. All right, kids. What are we gonna learn about today? We're gonna teach you about some chemistry. We're gonna teach you about some chemistry, kids. It's gonna be great. We have here, we've got my lovely assistant, Teddy, over here. Hello, Teddy.
Today we'll be learning about chemical reactions. Well, there are two kinds of reactions, physical and chemical. Physical reactions are when the chemical bonds do not change, and no matter what happens, it stays the same substance. Chemical reactions are when the chemical bonds do change, and when it's over, you have a completely new...
Boring! Here, this, that's physical change. This is chemical change. Oh, Back to you, Teddy.
We just saw the combustion of cellulose, the primary ingredient of paper. Combustion is actually characterized by a reaction with oxygen, which in this case can see it coming off the paper as smoke and charring around the edges. The chemical formula for the reaction is right here. Reactants and products are pretty simple. As you can see here, 2H2 reacts with O2 to produce 2H2O, also known as water. You see, we have the reactants over here and the products over here. This is the same way with every formula. Solutions are made up of two parts. The solvent, and the solute. The solute, as seen watercoloring, is dissolved into the solvent, water. For example, you see, it will now dissolve into the water and become one.
All right, we're gonna do covalent and ionic bonds. Okay, so there. I don't expect you to understand, kids. You've never been in love, but there are two types of bonds. There are two types of bond, kid.
There are two types of bonds.
No.
Covalent and ionic.
Shut up. There are two covalence. Covalence is like sharing. It's like how Timothy never intended. Timothy.
Okay, covalent bonds are when the
No. Ions, man. Ions are electricity. They're charges. They're just like a constant state of love-hate relationships where then they move away they want. It's like your parents' marriage.
Whoa. Okay. Yes, covalent bonds share electrons because they are made up of two.
No. They share. They share like no humans have ever done. They're these tiny particles, and they've never known this.
Yes.
They've never known this before.
Yes, covalent bonds do share electrons. That makes them very distinct and different from ionic bonds.
No, they're special. They were special, like I was once.
Ionic bonds are formed when atoms from different sides of the periodic table come together. The nonmetal has a much higher electronegativity than the metal, so it takes the electrons away. In a covalent bond, two nonmetals come together. Because they're so similar in electronegativity, they share the electrons.
Synthesis is when two substances come together to be one substance, like this. Decomposition, however, is when one substance separates to become two substances. Now, single replacement is when one substance trades a component of the substance for another one, like this. Double replacement is when two substances swap components to become two different substances. And combustion. Combustion is when one substance reacts with oxygen to become a new substance, as we can see here.
Ooh! It's beautiful.
Oh, that's pretty. That's so pretty.
Yeah, that's it. So what the hell just happened? Well, I'll tell you. That man back there with all your pretty colors looked like a combustion reaction. Well, it's not. And I'll tell you why. Thermite is it's a particular little substance here. The oxygen comes from the rust in the iron, which means that it's not in the air around us. And in order to have combustion, you gotta have oxygen gas. Thermite doesn't make any gas, and it doesn't need any, which is why if you pour water on it, the only thing it's gonna do is burn the water. Steam burns, man. You don't want any of those. That's why they use it for welding the bottom of the frickin' ocean in the secret government testing facilities. What we just made is this right here, little doodad. Is Fe2, pure iron with just a little bit of aluminum oxide covering the front of it. You can see it's quite shiny. Here, come on. Zoom in. Zoom in. We have a zoom function for a reason. See that? It's pure iron. Well, as pure as we could get it. So yeah, there's your single replacement reaction, kiddos. Alright, kids, when you're ready to see something cool. Alright, I don't know what's gonna happen in here, so we just... Oh, what happened out here? I thought it was only... Oh, shit. Is it... Oh, shit. Oh, shit. Biologist! Biologist, get over here! You know that science stuff. What happened?
Dead.